let us have a quick demonstrations on the topics that we have learned in the last module. Our last module was based on the inheritance in Java. So, today we are going to have a quick demo on the topic that we have learned in the last class. So, in today's demo we are going to cover basic concept of inheritance, namely the simple inheritance, and then we will discuss about multi-level inheritance. We have discussed about the super keyword which used to avoid the namespace collision, the super keyword use of the super keyword to invoke the super class constructor, and then using the super keyword we can reference to some variable of the super class, and then overriding is an important concept in any inheritance. So, method overriding will be discussed. There are two more keywords, namely abstract and then final keyword, that is come on the way of inheritance. So, we will discuss this one. So, these are the topics that we are going to discuss in this demonstration lecture. Now, let us have a first demonstration on simple inheritance. So, how a class can be inherited from another class, we can see it. Let us have the demo. Now, let us watch this program here. In this program we see a class, namely class A is declared. This is the super class in this case. This class has two members I and j, and it has one method called the show I j, printing the values of I and j in this class. Now, in the next class, the class B, which is basically inherits the class A. So, class B extends A, and we can see that in class B we declare one variable called the k of type integer, and then class B has its own method show k, printing the variable k in this class, and also it has another method sum. It will print the value of I j which are inherited from the super class, and the value of k which is in its own variable. So, this is the inherited class B, and as you know, class B therefore, by virtue of inheritance have the access of both I j and the method show I j, which are declared in class A as a default access specifier. As they are in the same file, they are readily accessible by virtue of inheritance as well as default access specification. Now, let us have that main class. The main class here we name as demonstration underscore 61, and in this class we create two objects of type class A and class B, namely super OB and sub OB. So, two objects of two different classes are created, and in the next statement we initialize the values of I and j in the super class objects, and then also print. I call the method of show I j of the super class object, and in the next statement we see we initialize the subclass object I, j and k as 7, 8, 9, and then we display the values of show I j as it is accessible to sub O I b by means of the inheritance, and then also we call the show k method of the subclass object sub O b, and then we print it. Now, let us have a quick demo. So, you can see that this is all legitimate access. We can use this thing and it will give that results that we have initialized, and finally, it will also display the value accordingly. So, we run this program as using the Java C, then execution. So, fine. So, it will work because there is no error in the program and it will print accordingly. So, this is the value that this class will print for us. So, this is the first example showing how the simple inheritance in Java can be done. Now, our next demonstration is based on the initialization of the subclass object by the constructors that is there in the super class. So, this demonstration will show us how we can initialize a subclass object using the constructor which is defined there in the superclass. Now, let us have the program here. Here we can see the class box is a superclass class having 3 data with height and depth, they are declared as double, and the box is the constructor, it is the superclass constructor, default constructor, and in addition to this default constructor there is one more constructors is initializing the different values in the class objects, and also it has one method volume, it is just simple multiplication of the values of the objects. So, this is the class superclass. Now, we derive one class, give the name as box weight, it is an inheritance of the superclass is box here in this case, and in addition to W, H and D which are there in box class, we define another data weight of type W. So, this is the data of its own, and then we declare a constructor in this class box weight, which we pass the value there, and then initialization is this one. So, we can create an object of superclass as well as subclass here. In the main class we can see the main class is demonstration underscore 62A. So, we create an object my box 1 of class box, and then also we create another object my box 2 of the type my box weight, which is the subclass in this case, passing the values 2, 3, 4 and 0.076 as an argument to initialize the object, and then finally, we print the volume for the object. So, there we can see we have created a subclass object, we have created a superclass object, although no problem. For the superclass object there are 2 constructors. So, in this example the default constructor will be called, whereas for the initialization of the subclass object the constructor only constructor here that will be called. So, this program will be executed, and let us see the execution of this program. So, this program once is successful compilation and execution, it will print the volume of the both objects my box 1 and my box 2 which we have created. Yeah. So, you can see that 2 objects are successfully created, one object is the subclass object, another is the superclass object. Now, we have shown in the last example that how the subclass object can be initialized. Now, we are going to have another illustration where a subclass object can be initialized with the help of superclass constructor. So, this is the one program in this direction. It is simple as usual. Earlier the superclass remains same, wherever we just redefine the subclass object in the following. Let us go down. Yeah. So, here you can see we just have the 2 constructor, one is the default constructor in the subclass object, subclass the box weight, the default, and another is the with some values. Now, in case of default constructor we see we call super within this one, this basically call the superclass constructor in the superclass, namely box. Okay. So, it will call this one. So, it will initialize with the 0 0 0 values to the members. Now, again the super WH here basically it is the superclass constructor which has the 3 arguments that is required, and then we call this superclass constructor to initialize this using the box weight constructor here. Now, let us have the same demo here, it is basically same thing, we create 2 objects, my box 1 for the superclass object, my box 2 for the inherited class objects, and then it is basically same program as earlier, only the thing that we have initialized with the help of superclass constructor. Now, so in this demo the superclass constructor is basically super with certain argument, the argument which will fit with the superclass constructor will be used here in the subclass constructor. So, let us have the another demo. It basically super use of the super keyword, that basically how we can refer a subclass object with the help of superclass variable. Now, let us have the demo 6.3. Now, in this case we will see how the superclass variable can be referent to the subclass variable like this one. Okay, we can better explain this. Now, this is the subclass definition, class box. It is the same as earlier, it has two constructor. The class definition is same already that we have discussed here. Now, let us come to the superclass object. Okay, it is also same, it basically has the weights and then the only constructor here in this case. Now, let us see the main class method here. This needs to be checked very carefully. Here we define one object of subclass box weight, the namely weight box is the object passing the parameter for it. Now, in addition to this also we declare here another object plain box of class superclass box here, and volume is the volume to hold the volume of this one. Now, if we call the volume method for the weight box, so it will call the volume method in which is defined in the subclass, and accordingly the volume will be calculated. Now, so it will be printed. Now, so that is all. Now, let us come to the next one. Now, here we can see plain box is equals to weight box. So, it is possible here basically we are referencing a subclass with the help of superclass. Plain box is a superclass object and weight box is a subclass object. This kind of assignment is quite legitimate. That means, we can reference a subclass object name with the help of superclass object name, and next statement is also quite valid. Volume will be obtained for the plain box there. Now, again you can see which method will be called here. It is basically volume of the weight box method will be called here. Now, okay, let us run this program. .3 Okay, so we can see the volume that we can print here is the volume of the subclass object, but it is reference to the superclass object. Okay, so this is the one demo. Let us have the another demo. This demo is basically planned to explain using the usefulness of super to avoid the namespace collision. So, basically we can overcome the name hiding using the super construct. Let us 6.5 the demo. Yes. So, this is the one simple program that we can check it. Yeah. Now, here let us look at the program. Class A is a class declared here having integer as a variable in it, and class B is a inherited class from A, and also C I A integer is declared of its own. Now, here whenever by means of inheritance the variable I both that is there in the superclass is also accessible to the subclass, then it become a problem. It is called the collision. Collision means both I is there. Okay. Now, of course, according to the inheritance it basically overwrite. That means, the scope according to the C, this I which is declared in class B is basically I of this subclass objects, not that one. So, this I which is declared in the class B in fact hides the I which is already there in A. However, we can refer both the variable, and this reference is possible using the super keyword. Now, let us see the constructor which we have defined for the subclass object B is like passing A and B as the arguments. Now, if I mention super dot I, this refer to the variable I which is there in the superclass object, and similarly I if we do not mention anything, it basically refer to the variable I in the same class itself, that is here in the B. So, this way we can refer to some superclass variable as well as the subclass variable this way. So, super can be used to resolve the collision that happens in this case. So, rest of the program is very simple. So, method will print all the values those are there in subclass as well as superclass. Two print statement is used for that, and this is the main method. a sub object, subclass object is created, and then we call the show method, it will print the two values there. Okay. So, for example, 1 and 2 will be printed here, 1 will go to the I, the superclass values, and then 2 will go to the value to the subclass. Okay. Let us run this program quickly, so that we can see exactly whether it is running or not, and then we can have the understanding then that superclass can be used to resolve the name collision. Yeah. So, we can see that okay. So, it basically is successful so far execution is concerned. So, it works. Now, our next demonstration basically to see how the code sharing is possible. It is also a very good example of dynamic binding concept that is there. Actually, it is a runtime polymorphism concept, it is there. During runtime it will resolve which method is basically called here. Now, here we can see first we declare one class, the name of the class is cat, and it has one method speak, and then it basically print this meow statement here. Now, another class which is basically inherited from the class cat is a subclass pet cat of superclass cat. It has also the method speak, and this method has this statement meow. Now, here we can see the two methods are defined, but it is a method overriding. The speak method in pet cat overridden, then the method that is there in the subclass method cat. Now, we declare another one class also extension of cat. It is basically multi-level multiple is okay. We can say that two inheritances, two multiple single inheritance we can say here, because we inherit another class magic cat from the class cat, and we can define one variable is a boolean type no one. Now, void speak, if no one, if it is true, then it will call the super speak. Super speak mean in this case it will call the cat class speak that is there in the cat method, meaning in this case it will spin meow, and if it is false, then it will call this simple message. Now, let us see how dynamically we can bind to this. Let us have this program. This is little bit tricky. You can see how these statements are here. So, demonstration underscore 66 is basically giving the idea about runtime polymorphism in this case, but we will resolve it using the super concept here. So, here we create an object of a subclass pet cat C1. So, that is okay, very simple. Also, we create another object C2, the magic cat, and so C2 no one we mention true, that means if it is no one it will spin the superclass method for this C2. Now, again C2 speak, so it will call the method here. Now, C1 speak, if we call that it will call the another subclass object, that is the main one. Now, we can make C2 no one as false. So, it is now false, and if we call again C2 speak, then it will call the another method. So, it accordingly it will print meow meow and then hello cat. Now, let us see the run the program, we will see exactly how it will work. Yeah. Okay. Now, we can see this basically print according to the different statement depending on the concept it is there. So, this is one example. Here basically we can see that how that two or more classes can be inherited from one superclass. This also example signify this fact. Now, let us have another instance of multi-level inheritance. Multi-level inheritance means if we can derive from one class subclass, from subclass we can derive another subclass. So, like this one, the example of multi-level inheritance. Now, here let us see the class box, which is already the same as we have discussed in earlier demonstration, and also we use the boxoid, another subclass derived from the class box. So, it is more or less same as we have already discussed. Now, here the simple inheritance 2 level. Now, in the next level we inherit another. So, we define another class shipment. it is basically subclass of the class box weight. That means, box weight is a derived class from the class box and shipment is another derived class from the box weight. So, this is the shipment is an example of multi-level inheritance, and again for the same concept it is also applicable here. The multi-level inheritance can be initialized by calling its superclass constructor, in this case box weight constructor. So, super WHDM basically call the constructor that is defined there box weight. It is like this way and it is initialization. Now, let us come to the creation of objects. So, demonstration 6.7 is a program. Here we can create two objects, shipment 1 and shipment 2, and then we can call this method, it works. And then, so let us run this program, so that we can see the in the different for the two different objects which are derived in a multi-level way can be used to create objects, and then the different methods in those objects can be accessed via a Java program. Okay, so, this is an example that we can verify with the code, so that it is working correctly. So, this is an example of multi-level inheritance. Now, let us discuss about the abstract class. A class is defined as an abstract class. All the classes that we have discussed earlier, super class, they are with the access specification the default. So, they are default, there is no other access specifier, it is used here. Otherwise, we can use some other access specifier depending on its application. Now, here we use one keyword called abstract. If we specify an abstract keyword before a class, then that class is called abstract class. So, in this case base class is declared as an abstract, and also one method. If a method is specified by an specifier called abstract, then the method is called abstract. So, in this case a class is an abstract, and in this class one method is declared which is also an abstract. Even we can also declare a method without any abstract also, is called a non-abstract method, but in this case let us have the method is an abstract. Now, abstract class. So, what is the meaning of this abstract class? As we have already learned about that, if we declare a class as an abstract class, this means that no object can be created for this, but this class can be used to inherit some other class, means an abstract class can be used for super class, but no object can be created for this kind of class, abstract class. Now, let us have the one example here. We can see class derived is a subclass of the super class base. So, it is quite okay, and if there is any abstract method, then in the subclass the method should be declared and defined properly. So, the method, if you see abstract, whenever you declare an abstract, no code needs to be mentioned there. So, there is no code. So, it is a blank. Now, here you see in the subclass declaration we fully declare the method fun, and this basically includes one system, print statement, it will basically print this one. Now, let us come to the main method here, demonstration 6.1. Now, 6.8. So, here we can see, so here we can see if we uncomment the statement like base B new B, then okay, let us uncomment this statement and then try to run it, and we will see what is the consequence. So, this will give an error, because the base class here is an abstract class and we are not privileged to create any object. As you can see the error during the compilation, base B new derived, it is basically saying variable B is already defined in a method main like this one. So, basically abstract class cannot be instantiated. You can see an abstract class cannot be instantiated because it is like this one. So, let us uncomment comment it again. Now, have the next one base B new derived, this is quite here. So, now, see we can have the reference of base type by means of this kind of upcasting is quite possible there. So, now we create an object of type derived class, but reference it through a base class object, this is quite possible, and then we call the b dot fun as it is there. So, this fun is basically the fun method which is declared in the subclass method. So, this program if it is run, then it will give the output. So, this is working correctly. So, this is the concept, it is there. So far the abstract class is concerned. Now again here that whether abstract class, okay, we have understood that no object can be created. Now, whether abstract class can have any constructor or not. So, our next example showing this thing that yes, an abstract class may have its own constructor. That means, abstractor can be used to initialize the member elements if it is there, if it is not any object created even. Actually, this constructor will be useful to initialize the object of the subclass of this class, because for an abstract class subclass can be created. Now, here is an example where we can see how an abstract class can have its own constructor and how the same constructor can be useful to initialize the subclass objects. So, here we can see base is a abstract class constructor, here it basically prints same statement, and then next is basically an abstract method, namely the fun here, and the derived class is a subclass of the class base here, and derived is a constructor of its own, it derives it there, and void fun is the method which is basically implementation of the abstract method that is there in the base class. So, here derived is there, although this constructor is not called, that means superclass constructor is not called here, we can call it. Okay, I will tell you how this can be called here. Anyway, now let us have the demo about it. So, that means the constructor it is there, we can call it. Okay, we can just little bit change this program, whether base class constructor can be called here in this method in the derived class. So, we can do that. Yeah, this program is running fine. Yeah, so it is running. Now, let us come to the code again, switch to the code. Now, we can call the base class constructor here. So, in the derived class go to not yes kind. So, right next statement we can add here before right yes. So, you can write super, then within this one. So, basically super class constructor, namely base constructor will be called here, right. Okay. Then save it, compile it. So, here you can see both the derived class constructor as well as super class constructor will be called here, illegal start of type. Okay. So, can we write base here, simple base. Yeah, let us try whether the base call constructor can be called in this method or not. In this case super it does not work here anyway. So, the super class constructor cannot be used there, but we can use in the derived class constructor base class constructor, right. System dot out, yeah, you can just comment it, yeah, fine. Then within this derived class method constructor go there, right here, right. Then go to the two statement, right. One is that super, yeah, super within right, yeah, construct not 0, right, yeah. That fine. Now, okay, we call this constructor through the derived class constructor. Let us see whether it works for us or not. Yeah. So, in this case it works, that means a constructor can be called by means of the subclass constructor only. Now, let us run this program. Yeah, it will call the super class constructor as well as the base class constructor. Okay. So, this is basically okay, we have understood that a constructor can be declared in an abstract class and that same constructor can be used in the derived class objects. So, this is the one example. Now, let us have the another example where in the last example we have discussed that an abstract class with abstract method, but an abstract class may have the non abstract, that means without any. So, that method also can be accessed, but this method can be accessed through the subclass object. So, this is the one example that we are going to give a demo. Here the class base is the abstract class defined as an abstract keyword, and then it has the method fun, which is basically non abstract method. Now, we can call we can create a subclass object derived here inherited from the base class, and then the fun method is here, it is basically overridden method here, because we have overridden the fun method there, it is like this one. Okay, fine. Now, let us come to the main class here, demonstration underscore 610 main class, which basically create an object for the derived class derived d new derived. So, in this case you can understand d dot fun, we will call the fun method there. Okay. So, let us run this program, we can understand how it works for us. Yeah. So, it is derive is called here. Okay. So, derived constructor is called and derived fun is called. So, it is like this. Now, let us see how we can access the fun method which is defined there in the base class method. Okay. Let us come to the object here. No, yeah, here. So, now not here, these are the previous program, you have switched to the next one. Yeah. So, this fun method which is defined there in the base method is basically, it is allowed that okay, abstract non abstract method. Now, my question is that whether we can call this non abstract method here in the derived class or not. We can use it here, we can use as a super, right. You can use the super keyword. For example, in the fun method or somewhere, right, we can write super dot fun, right, and then this one. Now, you can understand that we use the fun method in the right. So, by super keyword we can refer to the method member which is there in the base class, although object is not created, but it will be accessed. Yeah. So, it is right. Yeah, we can understand this one. So, now non abstract method may be there in the abstract class, like non abstract data may be there in the abstract class, they can be accessed using the super keyword that is there in any subclass objects. Our next example basically demonstrating the final keyword that is there. Final keyword is a very strict keyword. If you declare a class as final, that means this class cannot be inherited in any other class, that means no subclass can be created from this one. So, this is the one example where bike is the one class we have declared as a final. So, final means no inheritance is possible. Now, this code definitely it is not a valid code, because we are attempting to create a subclass called Honda 1 extending bike class, and then definitely if it is not possible. So, the next statement main class is also not a valid one. Now, let us run this program, see whether this program gives a compilation error or it works. Okay. So, now we can see it gives an error that cannot inherit from final bike. So, this means that we cannot do this one. Okay. So, this is the one. Now, a question that arises that then what is the use of the final? Sometimes we can have a strict restriction that this class is a strict class, that no one class can be derived, because derivation means is an accessing some member in the super class. So, if we want to protect it, so we can fix the final keyword. Now, a class can be made as a final, like a method also can be made as a final, a variable also can be made as a final. Now, here is the next example that we are going to give a demo 6.12a showing that how a method can be declared as a final. If we declare a method as a final, that means this method cannot be overridden in any way. So, this is one example that we can see. Class base is a abstract class, that is fine, and there is a method fun which is declared as a final. This means that no overriding is possible. Now, here derived is the derived class, extend base class, it does not have any other method or members, is okay. Now, we can create an object of derived class, but referencing to base class, and then we call the b dot fun. So, it will basically call the that final method which is the fun method declared in defined in base class. So, this fun method is basically system dot out dot println final fun is called. Now, let us run this program, we can have the quick demo, so that we can see about it. So, okay, fine. So, this is running. Now, let us see whether we can override it or not. this is an attempt to override a method. This is an okay. Next demonstration, please. So, we can see we are trying to override it at one method which is declared as a final method in base class, and derived class we are going to override it. Now, let us have the quick look at the program here. So, here class base abstract method, and then fun is also final. In derived we have the method derived is a constructor, no issue. Now, void fun here is basically our attempt to override the method which is there in the base class. Now, let us compile this program. If it compiles, then means that overriding is successful. Now, let us run this program, compile this program. It is 6 to be, yeah, fine, right. Now, see, it gives compilation that derived cannot override fun in base. So, we have understood that a method, if it is declared as a final in superclass, then it cannot be overridden. However, it can be accessed in the subclass object by referring to this either super or this code. Okay, so, this is the demonstration about the inheritance and the many features in inheritance in Java program, and we have discussed so many things are there. If you advice is that you should practice all the programs that we have used in this demonstration, so that you can understand more, and if you have any doubt, any confusion, you can feel free to approach us, post your doubts in the forum, so that we can answer to your question. Thank you. Thanks for your attention.